Everybody, and happy Wednesday. Welcome to live stream number 34. Today is Wednesday the 26th, 2017. Man, do we have a lot to talk about today. All kind of stuff going on. Now, if you're watching this, you're watching the recording. Haven't got anybody in the live stream quite yet. Just hang on a few seconds. So if you're watching the recording, really appreciate you taking the time. Don't forget, down in the description area is my email address, and you can send me any future topics you would like to see here in this live stream. You can see we already got first people showing up. Absolutely awesome to see you guys. Got G in here. Love it. So today we got Bruises in here. It's great, guys. Really appreciate you taking the time. Now people are just coming in. I gotta stop paying attention to that. This is gonna be distracted. A lot to talk about today. We're going to talk about Fusion specifically because, as many of you guys have reached out on social, that the servers are down. So what's going on with that? Well, we're definitely going to talk about that and what's happening with all that. But before we get to Fusion and what's going on with that, we also are going to talk about impellers, turbocharger impellers, or turbine blade style. We're going to talk about that. But today is Awesome Wednesday. And what is Awesome Wednesday? Well, it is just few people have asked me about, like, who do I follow on YouTube? What specific products have I seen that I think is interesting? What is worth kind of like highlighting? So we got people all over the world and what's kind of like going on. And today on Awesome Wednesday, I got my t-shirt here. Scroll back. I think I got it a little bit big. Pull up a little bit. We got Grimmo Knives. Now, if you don't know about Grimmo Knives, don't worry. You will learn about them in just 2 seconds. Two brothers. It's John and Erik. I've never met Erik, but I met John. It's my fault that I've never met Erik because I've been invited to their shop. These two guys, these two Grimsmo brothers, have this awesome shop in Canada where they make knives. Let's jump over on the web here. So if you search Gris, it should come right up, you would think, right? It is Grimsmo. You gotta spell it right. Grimmo Knives shows right up here. You will also see Rask. You will see spinners, but this is the guys we want to talk about. Go in and you will find their web page right here. Now, there's a couple of things to know about the Grimsmo brothers and their awesome company. First of all, they are great friends with also John Saunders, and actually John Grimsmo and John Saunders, who we highlighted a few weeks back, actually have a podcast that you should definitely check out, where those two guys are kind of like talking about manufacturing, but also the whole thing about running a business and all that stuff. Now, I met John a couple of times, John Grimsmo a couple of times, and have actually held one of these knives in my hand, and I can tell you that the quality of these knives, they also make a couple of other things, but these knives are absolutely through the roof. It's absolutely they are absolutely beautiful, highest quality ever, and that's probably the thing that excites me the most. I think about these two brothers' work is they make everything on the knife because they really want everything to be perfect, and they do such a nice job with that. Now, on top of their website, where you will see that you can go and you can look at all the different knives they make. They also have a gears page. Here you can go and get the t-shirt. That's where I got mine. And you will see they have some spinners and some stickers and other things in here. They also have some testimonials, but they have their Instagram gallery where it's definitely worth checking out. Now, the other thing that is super exciting is John has a YouTube channel. And John does a really great job of taking you inside his shop and really sharing a lot of his thoughts and a lot of, like, day to day kind of thought processes that they're running through when they're trying to make these high precision, really great knives. And they used to be a Tormach customer, but have literally upgraded their machine to some really high end machines. So I would definitely recommend that you're checking out their videos. They are, of course, also Fusion 360 users, and one of the things I love the most about some of the stuff that they're showing on their YouTube channel is some of their fixturing is very cool. So if you ever want to see some really cool fixturing, you should definitely check out John Grimsmo's YouTube channel. So make sure that you go out online and you search Grimmo Knives and you check out their website, check out those cool knives, and go and check out the YouTube videos. I think that you kind of like, they're really inviting you inside of their shop and showing you kind of like the process, and it's just cool to see a couple of brothers creating really great high quality stuff. So that is Awesome Wednesday. Grimmo Knives. Go and check them out. All right, so back into, let me just check out here. We got 64 people in the live stream. Thank you so much for taking time out of your busy day to come in here and just spend 20-30 minutes or whatever here today. You can see that we got people from all over the place. We got people from Germany, we got people from Holland, it looks like, Belgium. We got people from Belgium, we got Mexico. You guys are awesome. Yes. By the way, no Fusion. Fusion is still down. Let's talk about that. Isn't it just convenient that it's still going on while I am going on live here? So let's open up Fusion. If you have not been in Fusion today, this have gone unnoticed. But if you have, you might have noticed that you got a kind of a flag up here that shows you that Fusion right now, there's an outage detected. And this is the Fusion team who are telling you that Fusion 360 temporarily is offline, and this is affecting all the online workflow. Sorry, guys. I'm sorry this is happening. But I guess that is kind of like the nature of some of these things about running on the cloud. Now, I know for a fact that the guys who are a lot smarter than me at Autodesk are working fiercely on getting this all straightened out. So I don't want to take too much time talking about this because I really want to get into today's topic, what was impellers, turbochargers, kind of the topic. But so if you're brand new to Fusion, this might be a little bit confusing what is really happening. So Fusion runs partly on the cloud and partly local. Well, Fusion is running local on your machine, but we know that we have the storage of all your files, and sharing can go on via the cloud. I don't know all the ins and outs of this, so I don't, whatever I say, don't drag me to court for this. But pretty much what happens is that most of this data is living up on through like the Amazon servers, and sometimes things is not working, I guess, quite as it should, or there's some kind of, it's not maintenance, I know that. It's clearly that there's an issue. Now, the way it affects you inside of Fusion, this is really important to kind of like just understand, because they did a huge overhaul of this lately, what personally I was really happy to see. It was great development. First of all, that you do get, a notification in here. And then actually also after I was sitting a few minutes and kind of like, you it's a little bit like if you're losing your internet that you wait, 5-10 minutes, you get a cup of coffee, and then you come back and you're like praying that it's back. But I actually noticed that suddenly that there was a link here. So if you click this link, and of course that opens up on my other monitor, you get this health dashboard. And you can actually see right here where the issues are. So this is, I guess what I liked about this is that this at least tells you that it's not on your end, that things are not working. It is on our end, on Autodesk ends, that there's something going on. And like I said, I mean, this is super inconvenient for absolutely everybody. And I, again, if on behalf of being an Autodesk employee, truly sorry that this is happening. And I know that the guys are working on it. Now, it doesn't mean that you cannot work inside of Fusion. There's a couple of things that affects, and we've talked about this in previous live streams, about the whole, in your preferences, you can control like the offline cache time periods. So what that means is that right now mine is set to 60. Depending on how much hardware you have on your computer, you can opt this if you want to. Of course, now it's when I'm offline, it's a little too late to do anything here. But what it means is that what I've been working on the last 60 days, in my case, are available to me to work on. It is all the stuff that I haven't worked on the last 60 days that sadly right now I cannot access inside of Fusion here. Now, what they have done in the latest update, besides giving us this little update area here, like I said, just nice to know that you're not the only one, is that you now are having the full folder structure in here. And if I go into a folder that I know that I actually have been into lately, let's see. There should be one folder in here. And now, of course, I just missed my, let's see here, 3 plus 2. Yeah, let's just go into this 3-axis in here. You will see that these two files looks, they are sharp, where the other ones, this one is also sharp, but this one is sharp, but these 3, 4, 5 files here, I hope it shows up on the live stream, they're pale, they're out of, I don't know, they're not out of focus, but they're, what do you call it? They're kind of like a little grayish, and I'm looking for the right word. That means that these have not been opened on my hard drive in the last 60 days. What means that right now, yes, sadly, I cannot get into contact with those. Now, another thing that I actually honestly don't know, if I go in here right now to my preferences, let me open that up one more time. Okay, if you go into my CAM, you will see that my CAM cloud libraries are installed here. But of course, because I have been in there the last 60 days, that should still be available to me. If we go in here and look, I would hope. I actually don't know that. That's actually kind of, well, if we go in here to CAM and we go into our tool library, we will see that our cloud folder is here, and we will see that there is tools in here, that the last tools that I have grabbed. Now, but I would have to look into this because maybe the tools that I haven't used, are they not accessible right now? That's maybe something to look at. All right, this is, but so be aware of that. That is the story behind this. I didn't really prepare to talk too much about this whole thing today. This just kind of like happened because, well, this happened. Again, sorry. Hopefully, I will pray that by the time we get done with today's live stream, it's back up again, so everybody can fade it. That's right. Thank you. They are faded. That was what I was looking for. So yes, I know. I honestly, guys, I know that the guys who are specialists in this at Autodesk are working their butts off to get this resolved. All right, let's talk about today's topic. Let's talk about how to model up impellers or turbine blades or whatever we want to call it. So yes, because even though that the cloud is still down, we can still work inside of Fusion, right? And when it gets saved, then it's just saving it locally, and then as soon as they do get it all up running, then it will sync up with the cloud, and we should be all good. So we should be good to go in here and talk about these impellers. Now, every time I try to do something like this, where I'm trying to do like a how to model something up, I'm always trying to do it thinking about ways I can show you multiple things inside of Fusion. So I don't normally not always doing it the perfect way, but it's with an intent to show you functions that you may or may not have come across with this. So a few people have asked me how you will model up an impeller blade. Well, let's go back in here and just make sure that we all are agreeing on, when I'm saying impeller blade, what I'm talking about here. So let's go in here and search impeller blade, just so we can get a picture, and let's go to images. And what I'm talking about is something somewhat like this. Something in this type of style. So you will find this type of stuff, I guess, like in turbochargers, and in, it looks somewhat similar to like a turbine blade, kind of the same style modeling, I think, as you would have with that. Now, I am not going to say that I am a specialist in anything, and I'm especially not a specialist in turbine blades or in impellers. But I wanted to talk a little bit about how I would go about modeling it up, and hopefully just throwing in some of like techniques in there that maybe you find helpful. Do me a favor, in the comment area below, let me know, or just hit the thumbs up too. Let me know if this is helpful, or if it's because just modeling things up, just this is how you do this. I think it loses a little bit if we don't talk about some of these different functions that is hiding inside of Fusion that could help you. So let me know what you think about that. So I did a little bit of research online to see how people have modeled up impellers in other types of software, or other CAD software out there, and I want to put out a little bit of a warning about my attempt to do an impeller, because there's a lot of great models out there for doing impellers in different CAD systems, but they're cheating a little bit, right? Because they're just trying to make something that looks like an impeller blade, what I guess is our finished results. But in the end, we gotta model things to be able to manufacture it, or be able to do design changes to it. And I feel like that some of the examples that I found online, they were pretty impeller blades, but it was kind of cheating a little bit how they did it. So what I'm going to try to do a little bit here today, when we're talking about how I would model up an impeller blade, is a little bit more about the way that I'm thinking about doing that. So enough talking. We're going to start off a sketch, and one of these impeller blades, of course, are round. And one of the things that I maybe like to do is to, when I do rounds, if you've watched these live streams before, I like to use revolve, and I'm just gonna model up the base that this impeller blade, turbine blade's gonna kind of be on. So I'm just gonna sketch a line here, and this is not really important for what I'm gonna try to show you today. I'm just gonna give a couple of dimensions, and then let's just sketch the rest of this thing here, go down here, over, kind of like just draw it up as a box in the raw state here. And I can see already, right, that we have some things we gotta fix here. Go ahead and make that one vertical. That's always fun. Now we see some of the other issues that we can kind of like work on here. Let's grab a corner, move around. Okay, we need a couple of dimensions. Default dimension here. Let's make this one maybe 1 inch. And then we probably also need a length on this. Let's make this 4 inches. This is not important. So I'm waiting for my sketch, of course, to be full defined. And let's just revolve this thing around. So I'm going to use the revolve command. It says up, select the profile. That's going to be that. Select the axis to rotate around. That's going to be that one. And we kind of have the base shape of our impeller here. So we're going to have these blades going up here. And this is just, you know, kind of like, I don't have any dimensions on this. So it's going to be kind of, you know, the best that I can kind of like do. But one of the things that I want to come across, because like I said, that when I looked online and saw how different people have modeled out impeller blades, they're kind of cheating in the matter that it's all great to use tools that is inside of your CAD software to make your life easier. But normally when you do something like an impeller blade, like if you're going to do a turbo blade, there is certain dimensions you need to control, certain areas you need to control. So when you start modeling something like an impeller blade up, think about the things that is customer required. So I'm going to start a sketch here on the back end here, create a new sketch. And what I want to do is I want to create this blade. It's going to kind of like have a radius to it here. So I'm going to create this radius. One of the things that can be nice to use is actually to use construction geometry controlling that. So if I go over here and I just kind of like create a triangle here, just like this. Now this was just gets kind of like out of nowhere. Again, I'm going to put my horizontal relationship on this, and I can make this vertical here. Now, if you see here, I kind of like got this rectangle that now is pierced or coincident to the edge of our circle here. And that means I can kind of like control things with dimensions. Now let me add that radius. So I'm going to go into an arc, and I'm going to do a 3-point arc. So if I select 1 point to the center, 1 point to the end here, see now I kind of like get the radius. Now I'm assuming the radius is going to be specified on your drawing. Let's make that 4. But the location of this blade, that could definitely be a variable that's going to come in there. I've talked about that in other videos about when you try to design things up for the first time, try to think about what possibly the customer could come back and ask you to change, or what could be the defined areas. So I'm just going to go in here and make these 3 lines construction lines. So I'm going to hit X on my keyboard. So these lines are really for nothing right now. But if I put a dimension on this line here, you know, now I can kind of like, you'll see that everything got full defined. And this dimension now kind of controls where this arc is. And then we have the radius on that arc. So think about when you're trying to draw things up, like something especially complex, like a turbine blade or impeller, is that you get the design intent into your sketches. I'm going to stop this sketch right here. And you will actually see a neat function. So right now that sketch is visible in here. You can actually right click on it and you can say show dimension. And those dimensions will now show up. And that could be extremely helpful, especially if you're sitting right now with like a customer's drawing that is specifying these dimensions, that you kind of like have them there. I'm going to turn the audio on, and I'm going to open up a new sketch. And I'm going to open up a sketch on this plane right here. I can't reach it, so I'm going to just find it right there. So I'm going to open a sketch on this plane. And I'm going to start out with a line. And we're going to play a little bit around with this too. So I'm going to start out with a line here and go vertical up. And let's just go up, I don't know, that's 3 inches. Maybe we just go up 2.5 inches right here. And I'm going to add a radius to that. Now I can actually do that by clicking another line, select the endpoint. So now I have the line. Excuse me. If I move back to that point and I drag, I actually get a tangent arc. Now that's kind of neat. You can see we got the tangency right there. Now that of course is still blue. So again, make sure you define things with what the design intent really is on your part here, or on the important thing, right? What really matters. I don't know. I'm gonna make that 1.5 maybe, and then also add we need a radius on it here too. So now that is fully defined. So now I kind of have two sketches, and some of you guys already know what I'm going for here. I'm going for a sweep to use here. Now, so if you figure that out, cool. But I'm actually going to do something different here, just to kind of like take it another direction. I'm actually going to go into the patch area, because remember that we were in the patch the other day when we did kind of like the repair, or how we created like a core out of a complex thing. Because the neat thing about this is that if you are engineering or modeling up something complex shaped, many times when you're playing around with it, the thing with the solid is that it always has to solve. But as we now have created like these lines and we're putting our dimensions in it, if you're using the patch, we're just working with that one face or that one surface on it. So I am going to go into the patch environment, and in here you will see that we also have the different tools in here. So I'm going to go into the patch, the sweep command, and it works really just the same way as it does in the modeling environment. It's looking for a profile. I'm going to select our arc here, and then it's looking for the path, and I'm going to select kind of like our chain here. And what we get out of that is we kind of get that face. Now you will see there's kind of like a line right here, and that's because of that tangency arc that we create over that sketch. So this kind of have a little bit of the shape of our blade here, that it has the curve. But what you'll see in the picture is that things are kind of like, it's almost like a straight blade that kind of like got bent, right? It got twisted somewhat. So how can we do that inside of Fusion? Well, there's different ways you can do it, but there's something in there you should know about, and it's called guide curves. And it actually exists both within the sweep and within the loft, and it happens also to be both inside of a patch or surfaces, as we are doing right now, or the standard modeling environment that you're most used to. So let me just go ahead here and delete that sweep command we just created and bring us back to where we were before. And we don't see my sketches here. That's a preference, right? Go into preferences. And if you go into design, you can turn off auto hide sketch on feature creation. Sometimes I have it on, sometimes I have it off, depending on where I'm kind of working. But right now I like to see these sketches here. I might also decide to right click on sketch number 3 and say show dimensions. That might also be nice. So what we're going to do is we're going to create a guide curve. So pretty much we're going to take that sweep we just did and we're going to pull it towards a direction. Now I'm going to create a second plane that is in line with the endpoint of this arc. So I'm actually going to use that little construction geometry I created first off. So I'm going to go into construction, say plane along a path, and if I select that line, it will actually create a plane along that path, and I'm literally just going to pull it to the end here and hit OK. So now I have a path, or a plane that goes right through that point. Now I'm going to right click here, create a new sketch, and one of the things you could do is you could again create lines and arcs. But if you have never played around with this, whoops, not lines. If you never played around with this, you should know about splines. Now splines can get a little bit what should we say? They can get if you never played around with it. For some people, it gets a little like, what the heck is splines? Well, what a spline is really just a segment. Let me place one out here in space. Hit OK. That has some handles on the end where we can completely control. See how these handles here? We can control, not only you can see how I'm bending it, but I can actually also pull out in them and completely change, and there's one in each end, completely change this line. Now the nice things about splines is that they're keeping a constant curvature of it, and we're going to see the result in a second. Now one thing that people make a mistake of many times with splines is that they think that they got to place a point every single edge. Let's just delete this spline. Let me show you what I'm talking about. I'm going to create a spline from our from this point right here, the center point, and up till about where the same height as our sketch is. Now I'm going to hit OK. Now what I want to end up with, if I grab these handles, is I want to end up with a curve that looks maybe, I'm trying to follow a little bit how I want that blade to curve. So here I have something that might look pretty curvy. One of the things that many people think they got to do to create a curve like this is they make the mistake that they go into a spline and they click like every 2 seconds to kind of create that curve. Whoops, now I get to do it again if I don't hit escape. So they, come on, work with me. So many people think you gotta like follow and you gotta click all these different areas here to create a spline, and then you end up with all these spline points, and it gets really, really confusing to kind of control that, because right now every little segment of this is like alive and things pretty quickly go crazy. The trick when you're working with splines is as few points as possible. So again, like you saw before, click once, click twice, and make sure you hit that little check mark to end the spline, not escape like I just did, and then grab the handle in each point and kind of like start dragging out and make them kind of what you want. And if you go in here, let me see, if you go in right here, be aware of that there's a couple of options. One of them is you can actually insert spline points. So if you suddenly found out that you needed another spline, another point in there, you can add them. But start out with just, and we should talk about splines a lot more later, but start out with 2 and just kind of like try to pull in these handles to kind of like get the curvature you want. Also be aware of that you can use these relationships over here. So for example, I can make sure that these 2 relationships here are getting into to be on the same height, or I can add dimensions to them and things in that order, whatever you want. In this case here, I'm actually just going to give it a dimension from here to the point here, and place this dimension right here. I can control, and we can see that it actually moved on me. So let's make that coincident to the origin. There we go. And you could of course also add dimensions from here to here and get another dimension for whatever you want here. But normally, actually with splines, you normally can have a couple of dimensions to control them, but you normally don't fully define the spline like you normally do with normal sketch geometry. What I like to suggest is that when you find the shape you want, you can, here it's okay to use the fix and hit the fix icon down here to fix or unfix your spline lock it in. All right, I'm talking a lot here. So let's go ahead and stop this sketch and just see what I got. So I got the original line that goes up here with the arc. We got our following curve here, and we got the spline. Let's go ahead and try to do the sweep one more time. So I'm going to go in here. I'm going to now. This is where I was before. This is called a single path. Now, if I drop down, you will actually see here I get the option to use the guide rail. So now I get 3 options. So the profile is going to still be the same. That's going to be the arc. The path is still going to be along here. And then I'm going to add that guide rail. And you will see that when I do that, it now starts twisting our shape here. Now, you will see that we get a line like we did before, and this gets more and more kind of assembled here because of that tangent arc back there. Now, if I wanted to get rid of that, really all we could do was we go back to that original sketch right there, edit that sketch, we could delete it, and we could use a spline, because again, it got the constant kind of constant area for that one. So let's go ahead here and just make a spline that looks kind of like a little bit more uniform. Let's put a dimension on it just so I'm sure that it's up about the same height as our other one. So like that. Hit stop the sketch. Now you will see when I go in to do a sweep, still the guardrail, this is still the path, or still the profile, this is now the path, and this is now the guide rail. You will see that now we don't have that crest going around it because we got a continuous kind of arc. And you can adjust things in here, just so you're aware that there's actually some you can control distances for the different ones in here, what is kind of neat. So you can actually control kind of like how far it goes up for the different ones in here. All right, I'm gonna stop here. You could probably work more with this with the guide rail to kind of like pull it more towards it than we are doing right now. It doesn't look like it's pulling that much in it, but that's maybe just the nature of how I have it here. But what I wanted to show you with this, let me just hide the sketches. Now where we have this this face, because this is just, again, like talked about the other day, it's kind of like a blanket. We can actually turn it into a solid from right in here. And we do that by going to this area here and going and thicken it. So thickening it just means that now we're actually worried about our thickness. And that was one of the things I saw a lot of people when they were doing the other tutorials, were that they were concerned about the thickness of the blade to begin with, where I think that getting the right shape must, without being an engineer who works on turbo blades, I would think that that is the most important thing. You tell me if I'm wrong. So I can go ahead and thicken it here. So if I select that plane, you will now see that I can add thickness to it. So let's just go ahead and add a quarter of in here. Now, one thing that is kind of funny about this is, I don't know if it's funny, but this is now 2 different bodies. So you actually see that our surface is still sitting in here, but now we have the blade, because we thickened it, it became one body, and then we have the other one. So that is definitely something we want to do. Now, the other thing we have to do, though, is if you're looking at our blade, they kind of like have an arc following this curve here. So to do that, you could, and this might be cheating a little bit, but you could go in here. If I create a sketch on this plane here, we could go in and create something, I don't know, create a line, and I'm just going to sketch something here, go up to here, and then let's make some kind of an arc here. Actually, I don't want that. Let's go ahead and do a 3-point arc then, if it doesn't want to flip in my direction. Something like that. Of course, there should be a dimension on those. I'm running late now. I'm running long, so I'm going to hurry up a little bit here. What I'm going to do here is just create some geometry, and now I'm not even doing this. I can't stand that that's not horizontal. That's kind of funny. Okay, now that it's horizontal, at least what I can do here is, let's go back into the modeling environment. Then we could do something like a revolved cut. So let's turn those sketches back on. And the profile is going to be this. And the X is going to be this. And make it a cut. So then we kind of get that. Turn the sketches back off. So now we kind of see we're getting that profiled blade there. And now to get the remaining blades, we only created one, right? We could now go in and circulate that. And actually now, right now, this is bodies, so we don't have to select faces. We can just go in and do bodies. Select this one, and let's revolve around the axes. I don't know how many we should make. I don't know how many there normally are on one of these. Let's make a few of them here. Now, you will see that I get all these bodies in here, right? Now, but don't forget about the tool that one of my favorite tools, the combine tool. We can actually go in here and say the target body is this bottom, and then the tool bodies are actually each of our blade here. Around here, select each blade, like that, and hit OK, and they now all going to be, now that's just one body that we have kind of put together here. And the only thing I see is we kind of like got an interesting fold up here. Again, you would need I would need the data for these blades to be able to really do this, I think, approximately. This now I'm devoting to start doing what I preached earlier about. Don't just make things out of the blue. There needs to be some kind of there needs to be the dimensions and things like that. But there we have it. That is probably the closest. In about 20 minutes, I'm going to model up something to resemble a turbine blade kind of thing. But I guess the point I want to get across, if I haven't talked you to sleep here, is to really go in and make sure, if we roll back to the original sketches here, that you have your dimensions, that the blades, that when you design things inside of Fusion, that you really try to get the design content in your design. Like draw up the sketches that you need to use and get them dimensions, so you are actually, also if you have to come back and change this later, that you have them in there to work with. There was one guy who one time taught me an important lesson, that he would many times spend, a little bit of time before start modeling things up on the screen, thinking about what the customer could come back and ask them to change. Because if he could figure out what that would be, then it was, and he had that into design intent when he started modeling up, then that would be a good kind of like being ahead of the game. So in this case here, when you think about a turbine blade or an impeller, how many blades could there be on that? Would they come and change that bottom radius in there? And I would also say, I'm not going to show it now, but I would also say that I used the sweep to create this blade here, but you could possibly also have gotten away with using the loft. I'm not quite sure. I didn't test that out, but the loft would also have, so you selected the one side, and now you would just use the guide, what I call the guide curve, as your other one, and then your rail would be that last thing in there. And of course, I'm getting an error probably because I'm selecting that. So I'm using a center line here. You get the idea. So you might want to play around with either testing it out with a sweep, testing it out with a loft, kind of see how that goes. Wow, this was a long one, 45 minutes. Sorry, folks. I really try to keep them short, but I hope you got something out of this. So, like I said again, I'm definitely not the engineer who designed turbo blades. You're welcome to comment about that down in the comment area in the live stream chat. But I hope that you saw some tools that you may or may not, maybe some of them that you're like, the thickening command, building thing. Make sure you get your sketches right. Make sure, be aware that you can create a surface so you kind of concentrating on the most important things. Then you can thicken it from then and turn everything into to a solid. Let me just see in here. Looks like we got a good live stream today. Yesterday we had a little bit of issues. We got 77 people watching. I really appreciate it. And also you, of course, if you're watching the recording. I know it's kind of hard to catch these. Tomorrow's is, we're going to talk about the move command tomorrow. It's same time as today, 3 o'clock Eastern. And we're going to talk about, that's one of my favorite commands here. See, we got a lot of people in here. Really appreciate you guys taking the time with a lot of comments. I'm going to do as I normally do. I'm running late. I'm going to stop the broadcast. So if you're watching the recording, thank you so much. Make sure you go down to the description area below. You'll find my email address. You will also find the link to Grimsmo Knives. So go and check out their stuff. Super cool guys. Definitely worth a peek on their YouTube channel. And if you really like it, make sure you subscribe to that too. Hope you like this. Give it a thumbs up if you do. Thumbs down if you don't. If you have the time, put it in a comment. Love to, I assure you that I don't have time to reply on all of them, but I definitely read them all. So I really appreciate that, guys. All right, end the broadcast, and I'll be in the live stream. Till the next time, have an awesome day.